In this session, we're continuing to talk about inventory management decisions. So we've talked about the idea of how much to order, and we came up with the EOQ as being the optimal order quantity that makes our inventory management costs the lowest. And here what we're going to talk about is when to place an order. So the EOQ is how much to order, and a reorder point will give us a sense of when to place an order. So before we get started, you want to keep in mind that what we're talking about here is the continuous review system of inventory management. So you are continually reviewing your inventory. You're keeping an eye on how much stock you have, how much inventory you have, and then when it reaches a certain level, you're placing an order. So in order to get started with the mechanics of how you would calculate a reorder point for a continuous review management system, continuous review inventory management system, let's start with a system for when you have zero lead time. So the picture that you have here shows that you order Q at a certain point in time, you use up all of that inventory, it goes to zero, you place an order, and you have instantaneous replenishment. However unrealistic that is, we're saying that there's zero lead time, so there's instantaneous replenishment whenever you go down to zero. And there's a constant demand rate, so you are utilizing the material at the same rate. So you can see the nice similar triangles across time, which are showing that there's a constant rate of usage of that item. So when would you place an order here? The answer is obvious. When the inventory goes down to zero, you place an order. So the reorder point here is whenever inventory is zero. However, in reality, what's going to happen is there's going to be a lead time. There's going to be a lead time for when you place the order to when you receive it from your supplier. So let's incorporate some type of a lead time into this same system. And then what we're saying here is that depending on the lead time, let's say that you have a lead time of 5 days, you're going to say, when I have 5 days worth of inventory left with me, I'm going to place an order. So that's what is represented over here by that bump, by that horizontal line above the x-axis, which is showing that the reorder point is incorporating that lead time, which is the time that it'll take for the material to get to you. So what you have is, once it reaches that reorder point, remember you're continually reviewing your inventory, so once it reaches that reorder point, you will place an order, and then you will have an inventory position that will show up. So you'll keep track of that. That'll be the inventory position. You placed an order. Now it'll take some time for that order to get to you. By the time that order gets to you, your actual inventory position has reached zero. On the day that it has reached zero, you receive an order of Q, which in the continuous review system is the EOQ. So you receive that order of Q on the day that your inventory position has become zero. Now, before we move on to the actual mechanics of the reorder point for the continuous review system, what I'd like you to do is in order to relate this whole idea to something that we do on a day-to-day basis in our routine lives, think about this decision that you would have to make. So let's say that, however unlikely it is, that you buy your groceries online, right? So you have some lead time for when they get to you. So you order your groceries online and then they get to you. So take any regular item, and here I say salt because that's something that you might order online and receive it from your online supplier. What would be the main consideration for you to decide when it is time for you to place an order? What would be your main considerations in coming up with a reorder point? When would you say, I should place an order now so that I receive the salt in time? So take a moment and think about that, and we'll come back and relate it to the idea of reorder point under the continuous review system. All right. So when you place orders from an online grocery store, you're probably thinking about the time that they're going to take to process the order. They're going to receive the order. They might not process the order immediately. There's going to be some lead time involved there. There's going to be that lead time for them to mail your product to you, to send it, to courier it to you, and that's going to factor into the time that it's going to take for from when you placed the order to when you received it. And we call that the whole thing lead time. Now, what you're concerned about is your demand for that product during that lead time, how much salt you consume during that lead time. So what we're saying here is that if it takes 5 days for that grocery store to deliver the salt to you, you want to order that salt when you have 5 days worth of salt left in your pantry, right? You place an order when you have 5 days worth of salt left in your pantry, and you still continue to consume over the 5 days. It goes down to 0, and by the time you've received the order from that online grocery store at your doorstep, so you're in good shape. However, you don't know exactly what the consumption of that salt is going to be in those 5 days, so you may be concerned about some uncertainty in that consumption of salt over those 5 days. And it's the same kind of thing that companies are thinking about when they're thinking about a reorder point. So they're thinking about how much of a lead time there is and how much buffer they should have for any kind of misestimation for their own consumption during that lead time, whether we're going to have more consumption than what we expected. If it's lower, that's not going to be a problem because there's going to be excess. But if it's a higher consumption than what you anticipated, then you're going to run short in that lead time. So you basically want coverage for that lead time for the product to get to you. So when you figure in the uncertainty in demand into the same type of picture that we were looking at earlier, now the picture doesn't look as neat as it looked before. It doesn't have the straight lines that we were looking at in terms of replenishment of depletion of inventory. So it's not going down in a straight line. Here we have crooked lines that are telling us that it's being the inventory is being consumed at a different rate. You can see the reorder point, and the reorder point here is bumped up from just being what you need for the lead time based on an average. You're saying that we expect certain consumption during lead time, but you also are bumping it up based on the uncertainty, saying that what if we run out? Let's have some extra. And that's the extra that you're adding in there that is bumping up the reorder point to it being higher than what you saw in the other picture, which was based on just the average demand, there being no uncertainty. So how do we do these calculations? What do we base it on, rather? So the reorder point is going to be based on two important things, two essential things that you're going to figure in. One is going to be the probability distribution of demand. What does that mean? It means that you're going to figure in the standard deviation of demand. You're going to say, well, I expect my demand during the lead time to be 40 units, but it could be as high as 50 or 60 units. So that's what I want to cover because my demand during lead time could be between 40 and 50 or 60 units. So I want to cover all the way up to 60 units. The other thing that you want to figure in is what kind of service level do you want to give your customers? Now, what that means in terms of inventory is how much are you okay with running out at any point in time? Are you okay to run out 10% of the time, in which case you are saying you want a 90% service level? You don't run out for approximately 90% of the time, but you're okay with running out 10% of the time. And if you want a 95% service level, by what you're saying is that you are okay with running out 5% of the time. So that's the managerial decision that you have to make. What is the service level that you want to maintain? And then you have to incorporate the probability distribution of demand and come up with a reorder point based on that. So two things we're going to include in coming up with a reorder point. So you have the service level for the customer on the basis of which you have a stockout probability, and then you also have the probability distribution of demand. And what you see over here is what is used a lot when you're using any kind of statistical calculations, and this is your normal distribution. So we're going to base the calculation of the reorder point on the basis, we're going to base it on the normal distribution. We're going to take the properties of the normal distribution and use it to come up with a reorder point. So you have a certain stockout probability. You have the average demand during lead time, which is going to be the center of this distribution, which is basically saying if you maintain inventory at this average level, you're saying you're okay with running out 50% of the time, because 50% of the data in this distribution is to the left and 50% of the data is to the right. So if you're keeping average demand, you're okay with running out 50% of the time. But if you're not okay with running out 50% of the time, you're adding some kind of a safety stock, and that's going to be based on your stock out probability and the standard deviation of demand that you would have got from the data that you have on your demand. So let's go through the calculations for reorder point here, and then we'll go through an example to see how this works out. So reorder point is based on the demand during lead time, which, if we didn't have any safety stock, it would simply be, let's take whatever lead time we have, let's calculate the demand for that, and that gives us demand during lead time. The safety stock is based on something that we called a z-score. Now, if you remember this from statistics, a z-score comes from a standard normal distribution, and it's based on the probability that is to the left and the right of that point. So we'll take the z-score based on that, and in the case of this lesson, what we'll do is we'll just look at a table that's going to give us the different z-scores for different probabilities running out. So we'll take a look at that in a minute. So for now, let's just call it a z-score. And then we multiply it by the standard deviation of demand during lead time. Right? So we might have a standard deviation per period, and we convert it to a standard deviation for demand during lead time. And what you see on the bottom of the screen there is you're calculating the standard deviation for demand during lead time by taking the standard deviation per period, multiplying it by the square root of the lead time. Square root of LT is the square root of the lead time, and that's giving you your standard deviation for demand during lead time. Right. I promised you that you would see a table that's giving you all the different factors of service and all the different z-values for those factors of service. So here you have that table which says 75% service level translates into a 0.67 z-value, going all the way up to 99.99% translates into a z-value for 3.72. So what this is saying is that if you want a certain service level, you enter the z-value, the corresponding z-value from this table. And for those of you who are familiar with statistics, this is something that can be calculated or taken easily from an Excel function based on norms inverse. So you put in the probability into that function, and you get the z-value based on that. So you can do this easily for any probability that you want to look at. Now, let's take this idea of reorder point and apply it in an example. So what you have here is average daily demand of 100 units, standard deviation of 30, lead time of 3 days. The cycle service level that is expected is 92%, so you're okay with running out 8% of the time. The z-value is given to you as 1.41 for that service level, and you're asked to compute the reorder point. So go ahead and use the formulation that we had earlier to compute the reorder point, and we'll come back and see what you find. All right. So the reorder point is going to be based on the demand during lead time, and then the safety stock factor, which is going to be based on the standard deviation, the z-score that you're going to get based on the service level, and we can calculate the standard deviation based on the lead time, square root of lead time that we're going to multiply it with. So here's your reorder point for this particular problem. It's going to be 100 units of average demand per day times 3 days of lead time. To that, we will add the z-score, which is 1.41, multiplied that by 30, which is the standard deviation, and multiply that by the square root of 3 in order to convert the standard deviation for lead time, convert the standard deviation into standard deviation for lead time. And this gives us a reorder point of 373. So what is this telling us? It's telling us that every time your inventory reaches a level of 373, if you are using the continuous replenishment system for inventory management, you will place an order which is going to be equal to the economic order quantity. So you reach a level of 373, you place an order of economic order quantity. And here you have the solution, complete solution given to you in clear type. So 373 is your reorder point. Right. Now we looked at what is called a continuous replenishment system as the system that we focused on for the calculations. There is, however, an alternative system that you can use. And you may be familiar with this system. When we describe it, you'll probably see that you're familiar with the system. It's called a periodic review system. And the main difference there is that in the periodic review system, the time between replenishments is fixed. So when I said you may be familiar with this, let's think of the vending machine that you might have in your building, in your office building, or in your school. That is being replenished at fixed intervals. There's somebody who comes there every week or every 4 days, whatever that fixed period is, and replenishes the inventory in there. What you'll also notice about that replenishment system is that the time period is fixed, but the quantity that needs to be replenished for every product is going to be different every time it gets replenished. So if you have 10 slots for M&M candies in that particular machine, on some days that the person comes back to replenish, all of those slots might be empty, in which case the replenishment quantity becomes 10 units. Some days only 2 of those might have been used up, so the replenishment quantity becomes 2. Some days none of those might have been used up, and the quantity is 0. So to contrast this with what we learned about in the continuous replenishment system, in the continuous replenishment system, you are having a fixed order quantity. We came up with the EOQ. That was the fixed order quantity. The time between orders is going to be different based on when you reach the reorder point. In the periodic review system, the time between orders is fixed. The quantity is not fixed. It's based on that particular target inventory level. It's the number of slots for the M&Ms that you have in that machine that becomes the target inventory level. You want to build it up to 10, and that determines how much quantity you would be replenishing at any point in time. So these are the 2 main types of inventory replenishment systems that get commonly used in all your inventory systems. And these are in place when you look at a larger ERP system that's making decisions for inventory. These are the basic ideas that are in place there. This basic EOQ formula that we learned about and the basic continuous replenishment system that we learned about can be looked at from a more sophisticated perspective if you were to relax some of the assumptions. So if you remember, we started off with saying there are no discounts for any item in terms of the price. The annual demand is constant, and we can take all of those restrictions and relax them, and gets to be a more and more complex kind of model for which the calculations obviously get more complex. But this is the model that we did look at is the basic model on which all of those other models are based.